Hey everyone, I hope you're doing well today. This video is meant to serve as sort of a practice session for you to get better at adding, subtracting, multiplying, and dividing fractions. Remember, the rules for adding and subtracting fractions are the same. If you can see any fractions that can be simplified, always do that first. Next, rewrite the fractions so they have the same denominator. We call this the LCD. It's the LCM, or the least common multiple, of the denominators. When you add and subtract fractions, you just add or subtract the numerators and you keep the denominators the same. You work so hard to find it, just keep it the same. Depending on the question you're asked, you may need an improper fraction or a mixed number. As always, when you found your sum or difference, make sure you check to see if your numerator and denominators are relatively prime. That means you're done simplifying. Multiplying fractions has a different set of rules. Remember to simplify each fraction before you begin. If you have a whole number or a mixed number, make sure you rewrite them as improper fractions. Be on the lookout for cross-canceling, because that's going to save you some time with simplifying later on. Multiply the numerators together and multiply the denominators together. Your product will be an improper fraction or a mixed number. If you cross-canceled earlier, you probably caught most of the simplifying, but just in case, double check to see if there's any more simplifying to do. If you already know how to multiply fractions, dividing fractions isn't too bad either. First, you're going to simplify any fractions that can be simplified. Then you're going to rewrite the division problem as a multiplication problem. We do this by reciprocating the second fraction and multiplying. Once you've turned it into a multiplication problem, just follow the steps for multiplying fractions. Now that we've reviewed the rules to follow, let's start practicing. Here we have 5 practice problems that involve adding fractions. Take out some paper and something to write with, and get ready to try some of these on your own. Pause the video before I go over the answers, and unpause when you're ready to check to see how you did. Let's start off by adding 5/8 and 7/12 together. Notice right away that they have uncommon denominators. We're going to look right here at 8 and 12 and see if we can find common denominators. Underneath here, I'm going to use the ladder method to find out what the LCD is. 4 is going to be a common factor. We're left with 2 and 3. Multiplying these diagonals here, or these diagonals, we find out that LCD is going to be 24. I'm going to write that down right here. LCD is 24. To get there, 8 is going to multiply by 3, and 5 is going to multiply by 3. 12 is going to multiply by 2, so 7 has to multiply by 2. Our rewritten fraction is going to be 15 over 24 plus 14 over 24. Now that these denominators match, we can add the numerators to get our sum. Since 15 plus 14 is 29, we're going to have 29 24ths. As a mixed number, this would be 1 and 5 24ths. Either one of these represents the sum. In this problem, we have 14 over 21 plus 10 over 15. Right away, I notice that 14 and 21 are both divisible by 7. If we divide them both by 7 to simplify, we're going to get a new fraction of 2/3. This means the same thing. Looking at 10 15ths, they also have a common factor that we can use. In this case, it's going to be 5. If we divide 10 divided by 5, that's going to be 2. And if we divide 15 divided by 5, that's going to be 3. It's a good thing we simplified first, because 3 is already our LCD, and we don't have to do any extra work to do that. Also, we have much smaller numbers to deal with here. 2/3 plus 2/3, if we add the numerators, is just going to be 4/3. This is our final answer, and we can write it as 1 and 1/3 as well. In this next one, we have 20 over 24 plus 24 over 27. Looking at 20 over 24, I notice they can be both divided by their GCF, which is 4. The new fraction you would get is going to be 5/6. Looking at 24 27ths, I notice we can divide both of these numbers by 3, which is their GCF, and that's going to result in having 8 over 9. Notice how these denominators don't match. Let's use the ladder method to find out what their LCM or LCD is. 3 goes into both of them, and we're left with 2 and 3. Our least common denominator is going to be 18. To get 18, it's going to be 6 times 3, and 5 does the same. And on the bottom of the other one, it has to be 9 times 2, and 8 times 2. Rewritten using the LCD, 5 times 3 is 15, 6 times 3 is 18, plus 8 times 2 is 16, and 9 times 2 is 18. Since these denominators now match, we can add them together. 15 plus 16 is going to be 31, while we have the same denominator here of 18. While this is the improper version, we could also say that this is 1 and 13/18. This would be the sum of these two fractions. In this next one, we have 30 over 45 plus 48 over 60. As the numerators and denominators get a little bigger, simplifying becomes a little bit more of a challenge. What goes into 30 and 45 is going to be 5. 5 goes into 30 6 times, and 5 goes into 45 9 times. Since 6 and 9 both have a 3 as a common factor, 3 goes into 6 2 times, and 3 goes into 9 3 times. Since 2 and 3 are relatively prime, that's going to be the most simplified version of 30 45ths. Now it's time to figure out how to simplify 48 over 60. Since these numbers are a little bit larger, I'm also going to write these on the side here and just simplify it down. I'm trying to use common factors that a lot of students would use so you can follow along with me. I'll start with 6 since that's a common factor for both, and we're going to be left with 8 and 10. 8 and 10 have a common factor of 2, so this simplifies down to 4/5. 48 over 60 is equivalent to 4/5. In order to get that, we divided both of these numbers by 12. Please note that 3 and 5 aren't the same denominator. Since they're relatively prime, we could actually just multiply them by the other denominator to get the common denominator. 3 times 5 and 5 times 3. When denominators are relatively prime, multiplying them by each other will always get you the LCD. 2/3 is equivalent to 10/15, and 4/5 is going to be equivalent to 12/15. Since these denominators are now the same, we can add the numerators. 10 plus 12 is going to be 22, and we still have 15 as our denominator. We can write it as an improper fraction, or as a mixed number, it's going to be 1 and 7/15. This represents our sum. Here's the last addition problem. We have 56 over 80 plus 42 over 56. Since these numbers are a lot larger and I don't want to find the LCD for 80 and 56, let's see if we can simplify each of these fractions first. 56 and 80 both have an 8 as a factor. 8 goes into 56 7 times and goes into 80 10 times. Since 7 and 10 are relatively prime, it looks like 8 was our GCF. Dividing 56 by 8 and 80 by 8, our new fraction for that is going to be 7/10. Now let's see if we can simplify 42 over 56. 42 and 56 both have a common factor of 7. 7 goes into 42 6 times and goes into 56 8 times. 6 and 8 are not relatively prime because they're both even. Putting a 2 on the side, 2 goes into 6 3 times and 2 goes into 8 4 times. Dividing 42 by 14 and 56 by 14, which is their GCF, we would get the resulting fraction of 3/4. Unfortunately, we don't have common denominators here. 2 is a common factor and we're left with 5 and 2. Multiplying the diagonals here, we can say the LCD is 20 looking at either of these crosses. Since 20 is the LCD, we need to get there by multiplying 10 times 2 and multiplying 5 times 4. Whatever you do to the bottom, we also have to do to the top. These new equivalent fractions are going to be 14 over 20 plus 15 over 20. Now that they have common denominators, we can add these two fractions together. 14 plus 15 is going to be 29, and we still have a denominator of 20. We can write this as a mixed number if we want and say it's 1 and 9 over 20. This would be our answer here. Now let's try subtracting fractions. In this first example, we have 7/9 minus 1/6. Notice how they don't have common denominators. To get the common denominator for 9 and 6, we can use the ladder method. 3 is a common factor, and we're left with 3 and 2. Multiplying these diagonals, we'll get 18 either way. That means that 9 times 2 is going to be 18, we'll do that on top, and 6 times 3 is going to be 18, we'll do that on top as well. The rewritten fractions, 7 times 2 is 14, 9 times 2 is 18, minus 1 times 3 is 3, and 3 times 6 is 18. Now that these denominators match, we can subtract 14 minus 3 to get 11 over 18. This would be our difference, or our answer. Let's try another one here. Now we have 12 over 18 minus 2 over 24. Right away, I notice that 12 and 18 are not relatively prime. We could divide these numbers both by 6 to simplify them fully. Simplifying 12 and 18, we're going to get 2/3. Now let's subtract the other fraction. Dividing them both by 2, we're going to get 1 over 12. Since we don't have common denominators, we have to get them. Since 3 is a factor of 12, we can just multiply 3 times 4, and we're going to have 8 over 12 minus 1 over 12. Now that they have common denominators, we can subtract 8 minus 1 to get 7. The difference here is going to be 7/12. Now let's subtract 80 over 48 minus 15 over 45. Since these numbers are a little bit larger, I'm going to use the ladder method just to show all the details of how to simplify. First, 8 is a common factor of 80 and 48, and we're left with 10 and 6. Since 10 and 6 are even, we know they're divisible by 2. Dividing them by 2, we're going to get 5 and 3. 80 over 48 is equivalent to 5/3. 80 divided by 16 is 5, and 48 divided by 16 is 3. Now let's simplify 15/45. I think a common number a lot of people would use is 5. 5 goes into 15 3 times and into 45 9 times. Looks like 3 and 9 are both divisible by 3, so putting a 3 on the left side here, we'll be left with 1 and 3. Here we found our GCF is 15, so we can divide 15 and 45 both by 15, and we'll get a simplified fraction of 1/3. I absolutely love the fact that the denominators match here, so 5 minus 1 on top is going to be 4, and 3 is going to stay the same on the bottom. We can rewrite this as 1 and 1/3. While simplifying was a lot of work for this one, it was nice that they simplified down to common denominators. For the last two subtracting examples, I'm not going to be explaining each of the steps. See if you can follow along and understand what I'm writing. Now let's try multiplying fractions here. We have 4/9 multiplied by 6/8. Remember, we don't need common denominators here, so we can get right away into cross-canceling. Looking at the 4 and the 8, I know I can divide them both by 4, and that's going to make 1 and 2. Looking at the 6 and 9, I notice they're both divisible by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. I see that we still have a 2 and a 2 that can be cross-canceled, so 2 becomes a 1, and the other 2 becomes a 1. That makes sense because 2 over 2 is just one whole. Multiplying 1 times 1 in the numerator, we're just going to get 1, and multiplying 3 times 1 in the denominator, we're going to get 3. Here in this next example, we have 6/10 multiplied by 15. We have to write all whole numbers as an improper fraction, so we'll write 15 over 1. Looking to cross-cancel, I notice that the 10 and the 6 both have a common factor of 2. 6 divided by 2 is going to be 3, and 10 divided by 2 is going to be 5. Looking to cross-cancel more, we notice that 5 and 15 have a common factor of 5. 5 divided by 5 is 1, and 15 divided by 5 is going to be 3. Since the bottom numbers are just 1, we can't simplify anymore. 3 times 3 on top is going to be 9, and 1 times 1 on bottom is going to be 1. 9 would be our product here. Now let's try 12 over 18 multiplied by 27 over 24. Right away, I notice that 12 and 18 are both divisible by 6. Dividing 12 by 6, we get 2, and dividing 18 by 6, we're going to get 3. Looking at 27 over 24, they're both divisible by 3. 27 divided by 3 is going to be 9, and 24 divided by 3 is going to be 8. While we could multiply and simplify later, we can look for more cross-canceling now. 2 and 8 both have a common factor of 2, and we're going to get 1 on top and 4 on bottom. 3 and 9 can also be cross-canceled by 3, so 3 becomes 1, and 9 becomes 3. Multiplying the leftover numbers, we have 1 and 3 on top, and that's going to be 3 as our numerator, and we have 1 times 4 on bottom, and that's going to be 4 as our denominator. 3/4 is our product. Notice how in this next example, we have mixed numbers. When multiplying mixed numbers, we have to convert them to improper fractions first. To convert these to improper fractions, we're going to multiply 5 times 3 to get 15, and add the 3 to get 18. 3 and 3/5 is equivalent to 18/5. Converting 6 and 2/3, we're going to have to multiply 6 times 3 to get 18, and 18 plus 2 is going to be 20. 6 and 2/3 is equivalent to 20/3. Now that we have improper fractions, we can look to cross-cancel. Turns out that 5 and 20 have a common factor of 5. 5 divided by 5 is 1, and 20 divided by 5 is going to be 4. 18 and 3 have a common factor of 3. 18 divided by 3 is going to be 6, and 3 divided by 3 is going to be 1. Multiplying the leftovers number together, 6 times 4 is going to be 24 on top, and 1 times 1 is going to be 1 on bottom. 24 wholes is our product. Let's try one more of these together. We have 3 and 3/8 multiplied by 10 and 2/3. Remember, we can't multiply mixed numbers as they are, so let's convert them to improper fractions. 3 times 8 is going to be 24, and 24 plus 3 is going to be 27. 3 and 3/8 is equivalent to 27/8. Now let's convert 10 and 2/3 to an improper fraction. 10 times 3 is 30, and 30 plus 2 is going to be 32. The equivalent fraction here is 32/3. This 8 and 32 have a greatest common factor of 8, so 8 divided by 8 is 1, and 32 divided by 8 is going to be 4. This 27 and 3 have a common factor of 3. 3 goes into 27 9 times, and 3 goes into 3 1 time. Multiplying these leftover numbers together, we have 9 times 4, which is 36, and we have 1 times 1, which is just going to be 1. Our final product here is going to be 36. Finally, let's try some division practice problems together. In this first problem here, we have 8/9 divided by 6/9. Right away, I notice that 6 and 9 can be simplified by dividing them both by 3. In doing so, we're going to get 2/3. Rewritten, we have 8/9 divided by 2/3. Now we have some smaller numbers to deal with here. To divide fractions, we have to multiply by the reciprocal of the second fraction. Remember we said that we're going to keep, and then we're going to change, and then we're going to flip. When rewriting this as a multiplication problem, we're going to keep the 8/9, we're going to change division to multiplication, and we're going to flip or write the reciprocal of 2/3 as 3/2. Now that it's a multiplication problem, we can cross cancel. 8 and 2 can cross cancel, and we're left with 4 and 1. 3 and 9 can cross cancel, so we're left with 3 and 1. Multiplying the leftover top numbers together, 4 times 1, we're going to get 4 in the numerator, and on the bottom we have 3 times 1, and that's going to be 3 in the denominator. We can write our quotient here as 4/3, or 1 and 1/3. Now let's try the second one. We have 15 over 18 divided by 10 over 12. Right away, 15 and 18 are both divisible by 3, so we can simplify that down to 5 over 6. 10 and 12 are both divisible by 2, we can simplify that down to 5 over 6. A little bit strange, but it turns out that both of these fractions are actually 5/6. It shouldn't surprise us that our answer here is going to be 1. But let's use our algorithm to make sure this is true. We're going to keep, we're going to change, and we're going to flip. Keeping the 5/6, we still have 5/6, changing the division to multiplication, and flipping 5/6 to 6/5. Notice whenever you divide a number by itself, everything is going to cross cancel here. 5 and 5 become 1 and 1, and 6 and 6 become 1 and 1. Multiplying these leftover numbers together, 1 times 1 is going to be 1, and in the bottom 1 times 1 is going to be 1. The final quotient here is just 1. This makes sense from the beginning because anything divided by itself is always 1. Now let's try dividing a whole number by a fraction. Here we have 4 divided by 6/7. Let's rewrite 4 as an improper fraction, so we'll write 4 over 1 divided by 6/7. Let's rewrite this as a multiplication problem. 4 over 1 stays the same, or we keep, division changes to multiplication, and 6/7 is going to reciprocate or flip into 7/6. I can see here that 4 and 6 will cross cancel to make 2 and 3. Multiplying the leftover numbers here, we have 2 times 7, which is going to be 14, and 1 times 3 on bottom, which is just going to be 3. The quotient here is going to be 14/3, or 4 and 2/3. Now let's try dividing some mixed numbers here. Here we have 4 and 1/6 divided by 3 and 3/9. Right away, you should notice that 3 and 9 can be simplified down to 1/3. Rewritten, we have 4 and 1/6 divided by 3 and 1/3. Converting 4 and 1/6 to an improper fraction, 4 times 6 is 24, plus 1, which is 25. Rewritten, this is going to be 25/6. Rewriting 3 and 1/3, 3 times 3 is 9, and 9 plus 1 is going to be 10. That's the same thing as 10/3. Now let's rewrite this division problem as a multiplication problem. We're going to keep, change, and flip. 25/6 is going to stay the same. Division is now going to be multiplication, and 10/3 is going to flip or reciprocate into 3/10. Now let's look to cross cancel. The 10 and 25 will cross cancel to make a 5 and a 2 if we divide them both by 5. And a 3 and 6 will cross cancel to make 1 and 2 by dividing them both by 3. Multiplying these leftover numbers together, 5 times 1 is going to be 5, and on the bottom 2 times 2 is going to be 4. 5/4, or 1 and 1/4, will be our final quotient here. And here's the last example in the video. We have 4 and 3/8 divided by 10 and 2/4. Right away, I notice that 2 and 4 can be simplified down to 1/2. Rewritten here, we have 4 and 3/8 divided by 10 and 1/2. Let's convert these mixed numbers into improper fractions. 4 times 8 is 32, and 32 plus 3 is going to be 35. This fraction rewritten as an improper fraction is going to be 35/8. Now let's convert 10.5 to an improper fraction. 10 times 2 is going to be 20, plus 1 is going to be 21, so this is going to be 21/2. Let's now rewrite our division problem as a multiplication problem by using keep, change, flip, and that's going to be 35/8 multiplied by 2 21sts. 2 and 8 will cross cancel to make 1 and 4, and 35 and 21 will cross cancel by dividing them both by 7 to make 5 and 3. Multiplying the numerators together, 5 times 1 is going to be 5 on the top, and 4 times 3 is going to be 12 on bottom. 5/12 is our quotient here. I hope you found this video useful in practicing your fraction operations. Being able to fluently work with fractions will absolutely help you in your math career. Keep up the good work, and I'll see you in the next one.